All right, for 1423, we run across a tiny little problem. All right, and that's simply that while we're still asking to do the same things, and find the rate law, we are no longer able to find two sets of things that double. For example, if you look at all of the concentrations for NO in this reaction, there's a 10, but there's never a 20. There's a 25, but no 50. There's another 10, there's a 35, there's no doubling of NO. The same thing is true for Br2. The bromine is either 0.2 or 0.5. So while there are times when one of them holds still, the bromine, there's no times when the other one doubles. So when we ask the rate law, there isn't really a convenient way to do it verbally. All right, so this one is just better to solve mathematically. So to find the rate order for NO, we'll use experiments 2 and 1. Again, because I always like to have a larger number on top so that I get a positive number out of it all. Now, it is still true that we can cancel out this term, and that's important. So we cancel out this term, and we cancel out the k's, and we end up with 150 over 24 equals 0.25 over 0.1 to the x power. This one here, 6.25 equals 2.5 to the x power. Now, we can just try some things. Like clearly it's not a zero order or first order, but you can just try it. You put in a 2 for the x, and you see it works out just fine. 2.5 squared is 6.25. So since we can expect these things to be, for the most part, whole numbers, 0, 1, 2, we can just test one. So x is 2. The reaction is second order for NO. Right. For bromine, we'll use experiments 3 and 1. That's where the NO concentration stays the same, so it cancels out. And the K cancels out. So 60 over 24 equals 0.5 over 0.2 to the y power. And we end up with 2.5 equals 2.5 to the y power. So even though this might have started out looking like there was something tricky to do with the numbers, the fact remains that y has to equal 1, and the reaction is first order for bromine. So my rate law is rate equals K times the concentration of NO squared times the concentration of Br2, bromine. Okay, then what's the average value of the rate constant from these 4 data sets? Since I know the rate law, I just have to substitute in for it. And very quickly, let me just show you, here's all 4 of them, where each one I just take the rate and the concentrations given to me in the table, plug them in, and you notice that I keep getting the same answer everywhere. Since this is third order overall, I know that this is to the second power and to the first power, so adding those up, I get the third order overall. That tells me what my units ought to be. So the average of 4 identical numbers happens to be the number. Now, here's the part we have to think a little bit. How is the rate of appearance of NOBR related to the rate of disappearance of Br2? Okay, we cannot use the rate law for this one. We have to go back to the chemical equation. The chemical equation, these two are disappearing. So as these two disappear, this appears. For every 1 BR that disappears, 2 NOBRs show up. So the coefficients tell us that this will show up twice as fast as this is disappearing. Oops. And mathematically, I can express it using that relationship we saw, that the negative change in the concentration of Br2 over time equals 1/2 the change in the concentration of NOBr over time. This is negative because this is a reactant and it's disappearing. And this one is positive because it's a product and it is appearing. So how fast, what's the rate of disappearance of Br2 when, and they give me the initial concentrations. These actually don't even have to be initial concentrations. These could be the concentrations anywhere during the reaction, because the rate law is always working from start to finish, even though the rate is changing. So the rate law tells me the rate of appearance of NOBr. So I just have to substitute in my concentrations to find out how fast this is appearing. That's my K, 12,000. Here's my two concentrations. I'm using the rate law, so it's raised to the second power here. So 12.5 molarity per second. That's how fast NOBr is showing up. From C, I know that the bromine is disappearing at half of that rate. So the rate that this is showing up divided by 2 equals 6.25 molarity per second.